Hello, welcome back to JD Science Prep. Today we are discussing predicting products of decomposition reactions. So there is one video already out in this series relating to synthesis reactions. If you are concerned about that type, go check that one out. And as always, if this video does help, please like and subscribe. So it says decomposition reactions happen when one species is broken down into two or more. Energy or heat is usually required to complete this process, and there are 4 strategies that we are going to follow while predicting the products of decomp reactions. So we're going to go through these 4 strategies, and then we are going to go through 4 examples where we pick a rule to apply to that specific example, and then write the products and then balance them out. So the first rule that we have is binary compounds decompose into their respective elements. So right now we have HGO, so that is consisting of mercury and oxygen. So why don't we just go ahead and write down our 2 elements that make this compound up. So we have mercury and we have oxygen. Whenever it's alone, remember it's O2, and let's go ahead and finish this off by balancing it up. So we have 2, 1, and let's put a 2 in front of mercury. That looks good to me. Next up, we have metallic chlorates will decompose into binary salts and oxygen. So what it means by a binary salt is basically just a ionic compound. So in this case, whenever it's a chlorate, and what it means by salt is whatever metal which is in this species, and it's going to be paired up with chloride. Okay, so that's going to be our anion. Our metal is going to be our cation. So right here, we already know that our salt in this case is going to be BaCl2. And then whatever is left over, which in this case, for this rule, it's just going to be oxygen. So it's just going to be O2 there. So we have, let's balance this out really quick. So we're going to have a 1 in front of barium chlorate, and we're going to have a 1 in front of BaCl2, and let's try a 3 in front of O2, and that looks good to me. Moving on to rule number 3, it says metallic carbonates will decompose into a metal oxide and carbon dioxide. So here we have beryllium carbonate, and we already know what carbon dioxide is, so we can just go ahead and write down CO2. And then we also have a metal oxide. So we know that when oxygen is in its, ionic form, it's going to be O2 negative, and our only metal in this case is going to be beryllium. So beryllium, if you were to take a look at a common ions chart or a periodic table, you would find that it's going to be Be2+. Those are going to neutralize one another since they are the exact opposite charge, 2+ and 2 negative. So we can go ahead and write out our metallic oxide as BeO. We got one more step. Let's quickly balance this up. I believe it's going to be 1s across the board. Okay, and also this relates to rule number 5 for our synthesis reactions, where it's basically the exact opposite. When we had a metal oxide reacting with carbon dioxide, it's going to make a metallic carbonate. Okay. It also kind of relates to the breakdown of H2CO3, as we are going to get CO2 and H2O. Okay, because basically we almost treat this acid as a metal carbonate, and it's just going to break down into carbon dioxide and then that metal oxide, where this hydrogen is almost seen as a metal. Okay, sorry about the sidetrack, but hopefully that explains that a little bit better than I did in our synthesis video. So moving on to our last rule, number 4, we have metallic hydroxides will decompose into a metal oxide and water. So we have a metallic hydroxide, which can also be called a base. Okay, so what that's going to break down to, we know what water is already, so we can write that down. We have H2O, and then it's going to break down into that metal oxide. So our metal in this case is Al3 plus, and oxygen, when it's in its ionic form, is O2 negative. Those can swap and drop to neutralize one another, and what we'll get for our metal oxide is Al2 O3, and let's go ahead and just balance this up really quick. We have 2, we have 3, and we'll have a 1 there. Everything looks balanced to me. Perfect. Now, moving on to some examples here. First, we're going to pick out the rule, and then we are going to apply that and figure out the products. Then we can go ahead and balance. So first off, we have zinc carbonate, and it's breaking down. Let's see if we have a metallic carbonate rule at all, and number 3 looks correct to me. It's going to decompose into a metal oxide and carbon dioxide. So we can go ahead and write down our metal oxide. So we have zinc is our metal or positive ion or cation, and it's 2 plus. And oxygen, when it's in its ionic form, is 2 negative. We've talked about that a few times. And that 2 plus and 2 negative will just cancel one another out. So we have zinc oxide, and then our other species is just carbon dioxide, which is CO2. And this looks like it's going to be 1s across the board. If you want to leave that blank, that is also okay. Number 2, we have RbClO3 or rubidium chlorate. Okay. Now let's look if we have a rule for metallic chlorates. We do. Number 2, it says that it's going to decompose into a binary salt and oxygen. So remember here, in this case, our anion that's going to pair up with our cation is always going to be the chlorine ion. So we have Cl negative pairing up with Rb positive, which is going to create our salt. So RbCl. And then we just have oxygen, which when it's alone, it's in elemental state, it'll be O2. And let's go ahead and balance that up. So I think it's going to be 2, 2, 3, and that looks good to me. Let's move on to number 3. We have iron 3 hydroxide, and the reason I know it's iron 3 is, I'll just draw this out really quickly. Remember, we have iron and OH negative. We are going to swap and drop that, which will result in what we were given from the question, FeOH3. That OH has to be in brackets because the 3 applies to both the O and the H. So let's go ahead and find a rule that applies to this. We have a metallic hydroxide or a metallic base. It's going to decompose into metal oxide and water. So let's go ahead and write down our metallic oxide first. So our metal in this case, we figured out it's iron 3 plus. Oxygen is O2 negative. These can swap and drop to cancel one another out, which will result in Fe2O3. And then we just have water as our other product. So we can write down H2O, and that is perfect. Let's go ahead and balance that really quickly. So we have a 2, and we have a 1. Let's try a 3 there, and that, I believe, looks good. Let's move on to our very last one. So we have silver oxide or Ag2O, and let's see if a rule applies to this one. So we have binary compounds decompose into their respective elements. Since we only have 2 different elements in this example, we can just split them into their respective parts. So we have silver, which is just Ag, and then we have oxygen as well, but remember, when oxygen is alone, it's going to be O2. 2. And let's go ahead and balance this up for our final question of the video. I think it's going to be 2, 4, 1. Perfect. So that is the video. I hope it has helped. If it has, please like and subscribe. Thank you very much.